Imagine a future where growing older doesn't automatically mean becoming weaker, sicker, or more fragile. A future where living past 100 is not rare, and where age-related diseases are delayed by decades. What if aging itself could be slowed down, or even partially controlled? Today, we're exploring anti-aging medical breakthroughs that could extend the human lifespan. For most of history, aging was seen as unavoidable. Doctors treated individual diseases like cancer, heart disease, or Alzheimer's, but aging itself was never considered a medical target. That idea is now changing. Scientists increasingly agree that aging is the single biggest risk factor behind almost every major disease. If we can slow aging, we may be able to delay many illnesses at once and dramatically extend healthy life. One of the most talked about breakthroughs in this field is a drug called rapamycin. Rapamycin was first discovered decades ago and has been used to prevent organ rejection in transplant patients. But scientists later noticed something surprising. In laboratory animals, rapamycin didn't just treat disease, it made them live longer. Rapamycin works by blocking a cellular pathway involved in growth and nutrient sensing. This pathway tells cells when to grow and divide. By slowing it down, rapamycin puts cells into a kind of low-power mode, similar to what happens during calorie restriction. For years, scientists have known that eating fewer calories can extend lifespan in many species. Rapamycin appears to mimic some of those effects without requiring extreme dieting. In multiple studies, mice given rapamycin lived significantly longer, even when the drug was started late in life. More importantly, many of these animals stayed healthier for longer. They developed cancer later, showed reduced inflammation, and maintained better physical function as they aged. But rapamycin is not a miracle pill, at least not yet. In humans, rapamycin suppresses the immune system. That's useful for transplant patients, but potentially risky for healthy people. High doses can increase the risk of infections and cause metabolic side effects. This is why scientists strongly caution against self-experimentation, even though some longevity enthusiasts have already tried it. The key question researchers are now trying to answer is whether low or intermittent doses of rapamycin could provide anti-aging benefits without dangerous side effects. Early human trials are underway, and some are investigating whether the drug could slow age-related immune decline or even delay reproductive aging in women. Rapamycin is not the only drug under investigation. Scientists are also exploring drug combinations that target multiple aging pathways at once. In recent animal studies, combining rapamycin with other medications produced even greater lifespan extensions than using a single drug alone. These combinations not only extended life, but improved strength, reduced inflammation, and delayed tumor development. This suggests that the future of anti-aging medicine may not involve one single breakthrough drug, but carefully designed treatment cocktails, similar to how modern medicine treats cancer or HIV today. Other compounds, like metformin, a common diabetes drug, have also attracted attention. Metformin appears to improve health and reduce age-related disease risk in some populations, but so far, its lifespan extending effects have been less consistent compared to rapamycin in animal studies. Beyond drugs, researchers are also studying cellular repair systems, genetic regulation of aging, and ways to remove damaged or senescent cells that accumulate over time. These approaches are still experimental, but they point toward a future where aging itself is treated as a medical condition. So what does all of this mean for us right now? The science is promising, but it's important to be realistic. No anti-aging drug is currently approved to extend human lifespan. What we have today are strong animal results, early human trials, and growing evidence that aging is not fixed, it is flexible and potentially modifiable. The real breakthrough may not be living forever, but living better for longer. Adding years of strength, clarity, and independence to life could transform society just as much as adding years to lifespan. We are still at the beginning of this journey, but for the first time in history, science is seriously challenging the idea that aging is inevitable. The question is no longer whether human lifespan can be extended, but how, when, and how safely we can do it. And the next few decades may change what it truly means to grow old.